Welcome to Let There Be Math again, and in today's video we're going to continue with the formula we derived in the previous video, which is essentially the integral of an exponential function of any arbitrary base a. Okay, so let's apply it to the first integral. Now for this one we're going to leave the function intact. We're just going to write down the same expression again, and now we're going to divide it by the coefficient in front of x, which is 4. And now we're going to multiply that by the natural log of the base, which is 3. And then we're going to add an integration constant, which we're going to call c. And that's it. That's our answer for that question. Now moving on to the next example, we have 10 to the power of x. Now the coefficient in front of x is 1, so that means that we're just going to leave it as that. And we're going to have the natural log of 10 in the denominator. Okay, so that's going to be our answer. Now for the next example, we start off with a function that looks like could be of the form that we're looking for, but we have the natural log of 7 to the power of x, so that doesn't actually look linear. What we're going to do is apply the properties of logs to actually reduce that to a linear expression. So we have 5. The x is now going to come down as a factor multiplying the natural log of 7, and then we're going to add 3 dx, and now we have this in the form that we want. So let's write it down as before. We have x times ln 7 plus 3, and now we're going to divide that by the coefficient in front of x, which is natural log of 7. And at the same time we have to multiply that by the natural log of the base, which is 5, and then plus some constant c. Now of course, in order to have this look exactly the same as the expression we started with, we can rearrange that to give 5 times natural log of 7 to the power of x plus 3 divided by natural log of 7 times the natural log of 5, and then plus the constant c. And that's essentially how you apply this formula for exponential functions where the base is anything other than the base e. In the next video we're going to continue with more examples of integration techniques. If you guys would like to see more content from Let There Be Math, make sure you hit the subscribe button, and I will see you guys in the next video.